Oops. Okay, so what we'll be doing here, we're going to talk a little bit about version control. And from there, we're going to peek under the hood of Git. We're going to do it in a hands-on manner. If you try to read any tutorial about Git, there are like two approaches. You're going to get the direct acyclic graph approach, or you're going to get, you know what, let's do the commands approach, or this is a tree figure it out approach. Hopefully, we'll find a better approach which involves a lot of kids' toys, and hopefully that'll help us out. So let's get started. Now, how many of you used Git before? Okay, how many of you used version control before Git? Okay, what did you use? Subversion? Perforce. Used Perforce too. Anyone use CVS? Oh, interesting.
Mercurial?
No, Mercurial's too current. How about RCS? If someone used RCS, I'll be impressed. You think you may have? Okay, Bazaar, anyone? Okay.
Yeah.
That's good. Okay, so what Git represents is a paradigm of version control that we call distributed version control. And this is a big deal in Git, and it plays a large role in its design and how it works. Initially, it was developed for the Linux kernel. So what happened is, when Linus Torvalds started working on Linux, he used a system of patches and tar files. So you have a tar file, you apply a patch for it, then you have the new kernel there. And they used that system for a long time. They needed better version control. They went through a couple of issues until BitKeeper came in the 1990s. BitKeeper was pretty good. It's closed source, so it's a proprietary software. However, they had a free version for any open source, for open source projects. And they started using that. They were pretty happy with it. However, BitKeeper changed their policy, and not everybody was happy about their policy towards open source software. So they decided that, okay, we need to switch to another system. However, since Linus, the way he treats the Linux kernel is that he's a benevolent dictator, so he said, well, I don't like any of the things out there, and like any Linux hacker will do, I'll make my own. So after he released Linux kernel 2.6, I think it was RC12, he sat down for 2 weeks and designed Git and wrote the code for it. Okay, it was written in C, and it had some shell scripts around it to help you navigate the system. At the beginning, Git was very famous for being the only version control system that only Linux kernel hackers can understand, but it went a long way from there. It's pretty nice and interesting. It's really good with large systems, and the Linux kernel, for example, has around 54K files with 15 million lines of code almost. So you know that it could handle business. The main goals for using Git or something like for the Linux kernel was it needed to have a distributed workflow. They don't want a single point of failure. And people who use Subversion or other centralized version control system will know that if the server is down, everybody's down. Okay, so it needed to be distributed workflow. It needed to have a very high performance because when you check out that number of files, even your operating system is going to choke, let alone any system that's serving you those files. Also, it needs to eliminate corruption. Does anyone know and this is a t-shirt question, does anyone know if there's an incident in Linux history that made this a very important issue, eliminating corruption? No, you don't count because I told you the story. Come on, go for it, Toby.
Well, you said it's there. I'm going to answer yes.
Okay. What is it?
That was my question.
Okay. So you may get a vanity sticker for that. Okay. So what happened is somebody wanted to introduce a security flaw in the Linux kernel. And they looked around, and they found that there is a specific comparison in the file system code where it says, let's say, if A equals B, he switched it from if A equals B to if A equals B. It's a very minor change, and he actually changed it in one of the servers that host the version control software that they were using. And it went unnoticed until someone came by and just was looking in another piece of code within that same area and noticed something looks iffy there. How come this changed is at X time, which is way after when this code was developed, and they caught the security flaw. So one important aspect of version control is what you give is exactly what you get back. Okay? And Git is very good at that. And of course, it's open source. That's why we're talking about it here. So what does Git mean? Well, Git is not a nice word. It's just a bad way of describing a person. Okay? And Linus has an ego where he says, well, I don't care. I name my projects after myself, and I'm not a nice person. So that's why he called it Git. So it's kind of an informal British word. Any questions so far? No questions? Okay, in case you didn't take a class with me, I usually like my lectures a little bit rowdy. I like questions. I like to interact. If I see a comment, answer back. That's fine. Okay? So please, I do not like a quiet room. It literally freaks me out. And you don't want to see me when I freak out. Okay, so version control. Now, I don't really feel the need to explain to people why we need version control, because any competent computer scientist or person who deals with code will be mature enough to understand why we need version control. Okay? So if you're working on a project, the most basic thing you're going to do is you're going to work on it, then you're going to just copy the whole folder, put it somewhere, maybe attach a date and time to it. That way you know, okay, this is my work up till this moment. And this is my work up till this moment. Well, someone could say, well, you know, I might as well just use Dropbox, right? They keep track of history, right? So what's the problem if you just use Dropbox nowadays for this? What's the problem with that? Anyone foresees any problem? If I have a project that I'm working on and I use Dropbox to keep track of history. Yes?
Space limitation?
Okay, I don't imagine at this level we'll have a project that's more than 2 gigabytes.
What if you're working on code that's a little bit special, so you don't want somebody else to know about your code?
Let's say my code is public, it's open source, I don't care who uses it, I'm developing it, I'm storing the files on Dropbox, and Dropbox allows, it has version history, right? So why can't I just use that?
What if two people want to make use of the same file currently and then merge them back?
That's a very good point. What if I'm sharing it with someone? Okay, another more basic issue. Yes? Well, you can work it. You can get it out of Dropbox too. You can use a different download different versions. But one important issue is, well, I worked on it now, and I worked on it like after 20 minutes, and I worked on it yesterday. So which version of class A belongs with which version of class B? So if I didn't touch class B for 2 days and I changed class A, which version of my class A still compiles with class B? Dropbox doesn't help you with that. It can tell you the history of the file, but unless you start matching time codes, you couldn't really tell, right? So keeping your own version database is a good idea, but it's not really a constructive way to deal with your code. The next thing is centralized version control, where you have a server that has all the code, and everybody pulls and pushes from that code. Okay? People who use Subversion are used to that system. It's pretty good. It worked for a while. However, there are issues with it. Can anyone raise some issues that, okay, I would rather do it a different way, or a problem that could happen? Come on. Help, guys.
Server goes down, nobody can work.
Server breaks down, nobody. Well, you can work, but
Well,
you notice
you're
that.
gonna commit changes or whatever.
So if you notice here that the version database is in the server, what you have on your computer, what you checked out, is the current version that you have. So if you want to go back and look at a previous commit that you had, you actually need to go to your server. If you want to do a git log and check who did what, you still need the server for that. So if you're on an airplane, well, who wants to code on an airplane, right? But if you're on an airplane or you're in like Burning Man or something, you actually need to access your log, right? Or if you go to hackathon and the web goes down, correct? So this is one of the problems. That's why we're looking for distributed version control. So everybody has their own copy of everybody has a copy of the database, and everybody has a checked out version of the code. And you can consult the database to check out any previous version you want. or even add extra versions you want, regardless of what's going on with other people. Is that clear? Okay. And then you can deal with the server in a way to make sure that everybody's keeping track of everything. Does that make more sense? Why distributed is actually works better in a good number of workflows? Okay. Please talk. I do not like a sleeping class. It drives me nuts. Okay. So version track. People who use non-Git version controls knows that, okay, the way Subversion, for example, uses version tracking is you have a file. If you change a file, it only stores the delta. What do I mean by the delta?
Change.
The change. Okay. So it stores the change, and then at any specific version, let me see if there's a pointer or something. At any specific version, it's represented by the change, and the file is introduced at a specific. So here, and then it changed 2 times, 3 times. So if you want to check out version 5, what does your system need to do? It needs to go, get the original file, start applying the deltas until you reach the last stage. Okay? Which works, which is fine, which is not a problem, and it works fine. However, this operation is kind of costly, right? If you're talking about a huge project. That's why Git uses a separate approach. It uses snapshots. A snapshot essentially is the whole project, your whole file system, at a specific stage. So here we have 3 new files. We added them to our file system. Here, only C and A changed. So those are new files. However, B is simply just a pointer to the previous B. Okay? And then when you come to the third version, well, actually, C only changed, and A1 is a pointer to the previous one, and B is pointer to the previous one. Now, you may see this as, okay, we're maybe wasting some resources, wasting some storage in this case, but count as how long does it take to switch between one version and another? How long does it take to switch from one branch of your code to another branch? It's simply just changing a pointer, right? Because all the files are there. It's important you understand. Any questions? It's important that you understand this part. I can discuss it again if you need me to. Because what I'm trying to, the goal of this presentation is not to get a cheat sheet and walk you through the Git commands. Because anyone can do that. There are a gazillion cheat sheets online. What we're trying to do here is make you understand Git. Because you could have used Git, you could have just worked with Git, but you understand how it works. So if you're in a pickle, you know how to get out because you know how the structure works. Okay? So, question? Yes?
How do the other version tracking work?
They store the differences between files. So file here, when file A and file C changed, it didn't store the whole file in a changed state. No, it only stored the difference between these 2 files. So if you remove the line, it just says, okay, this one line was removed and stores it here. So when you want to pull, and here another line was removed, here another line was removed. So when you check out version 5, you simply just remove the 3 files and you have the new version. So you actually need to do the calculation and applying the patches as you go along. Yes?
Since the version 2, you have to create branches, right?
You can create branches,
So
correct?
that's like the snapshot we're talking about. Yes. So what do you think?
But in Subversion, when you create a branch, it's a completely new part of your code. It's a completely new system, right? You check out, you have the whole code, repeat it somewhere else, and then you start working from there. In Git, that's not the case. In Git, just a pointer that you move. Okay?
In terms of checking out snapshot, branches kind of
I'm not saying you cannot do it. I'm saying this is how Git uses its internal structure. And this is one of the things we're starting here. Now, there's a rule of thumb. If you ever use any kind of version control, you will hate Git. Really, you will hate it. It will not make sense, and it's just weird, okay? Because it goes against almost all the conventions that other version control systems use. And I'm trying to avoid in this talk comparing Git with other things because it could be like a long talk, and it may not interest most of the people, but we can talk after the presentation if you want to go more after this, okay? Any other questions? Yes?
Can you say snapshot, like the actual content snapshot of the...
Yes, the whole contents. I think we spent enough time on this one, right?
So,
Yeah. What time?
7:30.
7:30? Okay. Okay, so get set up. Yeah, I have a lot of cool icons here. And by the way, we have the stickers for all of these. So you need to be nice in order to get one of them. So so who doesn't have Git installed on their computer? Whoever wants to follow up with me as we go along. Who does not have Git installed on their computer? Raise your hand. Okay, so Jay, can you help them out? Yes, you too? Okay. So, well, and if you feel like you want to help your neighbor, go ahead. We like a rowdy class here. So we have the document, everything that all the commands that I'm using here, everything that I'm gonna talk about is posted. Maybe we don't have all the descriptions, but we have all the code, okay? And it's up that on this website. So if you go to github.com/USC LUG, you're gonna see a good number of repositories, including the one from the last event. And this one is called Git Workshop, okay? And if you want to take a snap with your phone so you can type on your computer and follow with your phone, that's fine. I know it's kind of meaningless, but I thought it was cool. I tried to embed like a GitHub icon here, but it took too long that it wasn't worth it for me. You can just plug a sticker on the screen and work it down.
Can you go back to the link?
Sure.
Yes, actually.
It's github.com/USC LUG, and you can see Git Workshop there.
Yeah.
You're doing it? Thank you. Oh, okay. There you go. Okay, any questions so far? Good. So, how to set up Git? First thing you do is install it, which hopefully everybody did. Then you need to do a first-time configuration. Now, remember, you need to keep in mind when you work with Git that Git was created for an open source project where a lot of people contribute to the code. If you keep that in the back of your head, sometimes a lot of the decisions that you're going to go through will make more sense. Okay? So for example, some of the things that you do is, and by the way, we're not going to use any GUI in this presentation because I learned two things from people who use Git GUIs. One, they don't really understand how Git works. And two, they end up messing up the repository for everybody, and I have the proof for that. Okay, I'm a TA, and I know that the hard way. I only advise you to use a GUI once you understand how Git works, then go wild. Okay, but if you don't understand it, you're just going to mess up the repository for everybody else. So, after installing Git, we need to set it up, and the setup includes identifying yourself, identifying your tools, and then maybe just some security measures so you can access any server that you want to use your code with. Okay? So let's do that. Open up your laptops, terminals up, and if you're on Windows, make sure Git Bash is on, and if you're on your Mac, or just use terminal or iTerm to whatever works for you. So these are the only commands that I will not type today. The rest, we're going to go live with it just because I want to warm up my fingers. So the first command, git config global user.name. This is your name. Yeah, put your name, not Tommy Trojan, okay? We don't want Tommy Trojans in our talk today. So believe it or not, actually people do that. Like, I did this for like N times, and at least 20 people put Tommy Trojan.
What if your name is actually Tommy Trojan?
Well, then actually you should get a doctorate from USC, an honorary
I
doctorate.
have a student whose name is Trojan.
First name Tommy?
No, sorry, first name Trojan.
Oh, interesting. Okay. Well, those physics people. Okay. So, and then you put your email. Now, put any email, and we'll come to that later, but put the email you used when you register, the one you used in registering your GitHub account. We're going to talk about that later, but for now, let's stick with this. The reason you need to put your name and email is that one important part of code is attribution. You're authoring something, you're writing something, you're creating it. It needs to be attributed to you. Keep in mind, Linux kernel, open source project. That's why we need to identify ourselves. Okay? And then we need to say, okay, we like our UI a little bit colorful, so we want some red here, green there. It's not fancy, but it works. And then and don't get me started, Emacs or VI. I'm a VI guy myself. But
Oh, come on.
because I know a lot of people have Macs, and Macs don't have VI by default. Johnny gave me grief for that. Okay, so you put Emacs as your default editor. The reason for that is when every now and then it's going to pop up and ask you to write a comment. So you should have your editor ready for that. And then we're going to merge tool. Just type it as is. We'll talk about it later. And now we come to an important thing, and this is a T-shirt question. Okay, yeah, I got everybody's attention. Oh, thank you, Professor. So, I'm not sure most of you are old enough to know, but haven't you tried to get a text file from Linux or Unix machine and open it in Windows? What do you notice?
The encoding is different, so you see noise.
The encoding is different, so you see noise. Okay, encoding actually came later in the game. There's a more basic problem here.
Spaces sometimes are inserted that shouldn't be Windows.
Okay, who was? Somebody raised their hand. Yes, there? The line feed will be different. What is line feed? Come on. No, I explained it to you like a year ago. Yes. Uh-huh. Okay, it has something to do with typewriters. Go ahead. The new line character, close enough. Okay. Okay, what's the difference? Why is the new line character special? Yes.
I think, well, one of these, so there's \R is carriage return and \N is new line. And I mean, it's like Mac and Linux and
Okay.
Control M is added.
Okay, Control M that, you open it in VI, you come up with that. Come on, guys, I really want the answer for this one. Go ahead, Google it. I actually, if you go to the repo, I have a link to the answer. Go for it.
So on a typewriter, you have to move the paper as well as move the position where the
And you get a T-shirt. So there's a carriage return and there's a line feed. When you type on a typewriter, as you type, mechanically, you start going on there, tuck, 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 until you reach the end. Now, to start a new line, you need two operations in a typewriter. What are these two operations? You need to do a line feed. You need to roll the paper up to get to the next line. And then the other operation, you go back to the end, right? So like, and then you go back to the end, right? So you have carriage return /R line feed. It's a /F Evan, not a /N. So the order is different. Linux has it one way, Windows has it the other. That's why it gets confused. Okay? So remember when we said that Git actually wants everything exactly in, exactly out? Well, what if you have people developing on a Mac and then committing code, and another one in a Windows machine developing code, and another one on a Linux machine developing code? Which one are we going to use? Git will take care of that. That's why we have the auto carriage return line feed. If you are using Mac or Linux, to be more exact, Mac OS X and Linux, you use input, which essentially keeps it as is. If you're using Windows, you actually put true, which will automatically flip it for you once you commit code, and it'll flip it back once you get the code to yourself. So it'll take care of that for you. And that's neat, right? Like, that's like really awesome. Okay. The next thing that we're going to do is actually generate SSH keys. Now, when people talk to each other online, okay, not nowadays, but let's say you want to go to another machine online and you want to access it. We had the Telnet days where everything was open. It's like a freeway. You see who's coming, you see who's going. Now, that's not secure enough, so we create a secure shell where you create a tunnel between you and the other machine that you send the information through. Now, in order to create that tunnel, we are going to use, the standard way of doing it is using public key cryptography. You create a pair of keys, a public key and a private key. You send your public key to anyone who wants to talk to you. And then that person encrypts any data they want to send to you using your public key, which can only be decrypted using
Your private key.
who has the private key? You're the only one who has it.
What's the NSA?
Well, if you're... Okay, let's not go there. I still want to finish my degree. Okay. So what happens is, in order to talk to a server that you want, let's say you want to download code from another server, the best way to authenticate is just generate a pair of keys, give that server your public key, and then you can create an encrypted tunnel. Do I need to go through how? Not really. Okay. So everybody, let's go through this right now. I'm actually going to do this live. And switch monitors. I don't want my face to come on the feed. Okay. So in order to create one, first thing I want you to do an ls to tilde.ssh. Now, so if you're on Windows, you're using git bash, or in your terminal on Mac, we're going to run the same commands. That's why I love git bash. Okay? When you do enter, you're going to see either a set of files, or you're going to get no command. Yes?
Before we do that, do you want us to go through the sticker name and email?
Oh, you didn't do that? I thought I told you to do it.
Okay.
Oh, sorry. You know, the code is online. If you go to the... Oh, okay. So just plug it there. Because if you don't do that, actually another step going forward is not going to work for you. So this is where you save your SSH configuration. What we're looking for is two files, IDRSA and IDRSA pub. If you have those two files, ignore the next step. If you don't have them, let's do it together. So I'm going to pretend that I don't have them. So then we're going to generate a key, so SSH-keygen, and we're going to make sure we're going to use RSA just because we have one of the professors who made it here. And then we're going to, the byte size is kind of, you don't really need to put it, but just in case someone is following on a Ludra, we want to put it here. And then you insert a comment, okay? This is a capital C. And it's always a good idea to put a comment that will help you know what this key is for, or who does it identify. You may have a key for separate accounts. It has nothing to do with how the key is, how it's generated, or what it does, okay? The only thing it does is just insert this comment, append it to the key itself. Everybody with me here?
Just a question on when we're setting up the name and email and all the other stuff, what directory should we get?
It doesn't matter. Because it's a global configuration, it's going to go to a git config file, and it's going to stay there. Okay? Now, if more details on that later if we come to it. Okay, so we're generating a public key pair. It tells you where do you want to store the files. Okay? So, so you should keep it empty, but because I really want to keep my files, I'm going to put it somewhere else. So, okay? But you just keep it empty, keep it in the default place. Okay. And then it asks for a passphrase. Now, remember, you're the only one who can decrypt using your private key. Well, what if someone you left your machine open in the office and someone came up to your office and pulled out the key, which I did once. Okay? So, yeah, you need to maintain a certain reputation that you can hack into something, and sometimes this is the only way you can do it. So, so a passphrase is, what if someone got a hold of your private key? You just put a password on it. So even if they have the file, they need to put a password. You need to put a password in order to use it. Okay? If you're just doing this for the demo now, for simplicity, ignore the password. But you're advised to plug in a password for your key, and then enter the same password again, and then you should be done. The things to note here is where the files were stored, which should be in your SSH key, and this is the fingerprint plus the comment. It's like, for your key, it's like the phone number and the name that goes with the phone number. It's a way of identifying your key, okay? And the random art, this one is actually nice, like a double helix or some sort. Okay, so if we do it again, if you go to, you should see at least ID_RSA and ID_RSA.pub. This one is your public key, the one .pub. So never display your private key on your screen. Yes, Toby? Do you want it to, I remember there was a thread on it, I read it way back. I think the idea is, in order to distinguish between them easily without actually displaying the key itself, it's just an algorithmic way of generating an image. Unless someone knows a better answer, you need to roll with that.
A little more visual.
Yeah.
Basically what you just said. It's a little easier to tell those apart.
Yeah. So this is, for example, my public key that I use on this machine. Okay. Should I care that I have it in public? Not really. That's the whole point, having it in public. Okay. Let's go back to the presentation. If you're stuck on any stage, raise your hand. I may answer it live, or we have people roaming the room who could help you out. Okay? Now, let's get started. Yes? One is the ID underscore RSA, that's your private key, and ID underscore RSA.pub, that's your public key. So and you need a pair of those keys in order to authenticate using public key authentication.
Could I change the flight name?
You could, but here's the thing. Anytime you use any command that relies on those, you need to explicitly state the identity file, which you could do, but it's kind of a pain. Okay, questions? Okay. So.
Some people type in temp log as well. So.
Oh, okay. Just regenerate it.
So does anyone not see the ID underscore RSA file in the .ssh folder? Okay, okay. Yeah. So maybe go over that again without the temp log.
Okay. So let me do this. Okay. So here's what I'm gonna do: SSH hyphen keygen minus T RSA. Who can say the next command? The next minus B 2048 minus C, and then.
And that's in any directory?
It doesn't matter because it's going to default to your, well, it's going to ask you where to store the files. So it's going to go here, it's going to ask me where do you want to store the files. By default, it picks the right place and the right file name. So just leave it as is. Then it's going to ask you for an empty a passphrase. Pick the passphrase of choice. So, and then it's going to ask you to put the passphrase again. Okay, my bad. I put a bad passphrase. So long for an unscripted. Okay, so we put the passphrase again, and then you should get something like this. The key component here is that it's .ssh underscore RSA pub, and you have something that looks like this. Okay?
After the enter file, which you said the key, did you type anything else?
No, this is the last line I typed. This is the only line I typed, sorry.
That one and the passphrase?
And the passphrase, if you wanted to put one. Are we all on the same page? Okay. Yes, I can tell this one is ugly. Yeah, that one, I like that one. Actually, I want to keep those files. Like, yeah, you should. Okay. Okay, so now just ignore what I'm doing now. Oh, I need to delete. Do not do this. Do not do this. Like, can I be? Well, you're going to just regenerate the keys again. Unless you're using your keys for something else, then you're really going to hate me. Okay, so let's get started. Now, what are we going to do? We're going to try to learn how Git works while we're using the Git commands. And I'm going to have Johnny here actually illustrate what we're doing. We have connects, and we're going to use that to hopefully understand Git. So if you cannot see what he's doing, please raise your hand so we make sure that everybody understands what's going on. If you actually go to the repo, the GitHub URL that we sent, and you go under docs, there is something that's called hackset1, and I have no idea why I picked that name. Hackset1, and you'll have all the commands that I'm going to type up here literally there. So if you feel behind or you want to follow up, and I'm going to go as slowly as I can because remember, the goal of this is actually understanding it, not just memorizing the commands. Okay? So let's go. First thing I advise you, make a directory, and let's call it repo, for example. And make sure you're in a place where you want to work. Git bash or terminal.
So when you're doing this, make sure you're not in a Git repo already.
I didn't want to go there, but yeah, correct.
Like if you're using Git, get out of that Git repo, go to your desktop or something like that.
So I created a new directory. And I decided that for some reason, I want to keep track of all the files that I create in this directory. Okay? So let's create a Git repository. Do I need to go to GitHub? Do I need to create an SVN server? Do I need to set up like a SSH server? Or do I even need a web server to run? No. All I need to do is git init and to initialize a Git repository. And I just initialized an empty repository, and this is its place. So if I do ls, there's actually nothing in the repo, right? There's nothing in the repo. Who said no? What's there? T-shirt. So if you actually notice, there is a .git directory. Now, whoever used SVN has the .svn directory. So this doesn't look any weird. But the good part is this is the only .git directory. So if you actually used SVN before, you're plagued with the .svn folders in each and every directory you ever create in your project. So this is the only Git directory, and it's essentially the whole data structure of Git. It's your whole database. So if you take the .git directory, regardless of any other files you have in your repo, you zip it up, send it to another machine, unpack it there, you have the same repository that you have now. Okay? So what makes a Git repository? The .git directory. If you have it, you have a repository. If you don't have it, just a normal directory. Any questions so far?
I typed that in tree.git / and I got a dash tree from it.
Oh, that tree is not it's not standard in Mac machines. Sorry, this is for display purposes only. I should have. If you're on a Linux machine, it should accept it. Excuse me? Yeah. Okay. You can do like -r.tree, but sorry, .git. It's not going to look nice, but you get kind of the same result. Tree is just a pretty printing of a tree structure. Okay? Don't get me off my script. Sorry, please. I like that everybody is asking questions. Okay, so now we have a Git repository. Let's start by creating a file, and this is going to hurt when I do it. Emacs. Okay. No, what? Who's using Windows? What should they do? I forgot about that. Notepad? Okay. Who has a Windows machine? Can you turn the screen on? Oh, just something. Sorry.
Just want to create a file.
No, we don't. Oh, you're not. Who's following with me? Who has Git bash open? Someone close by. Here. I have a bad foot. So sorry. Yeah. Thank you.
Yeah, you can use whatever editor you want. You're not restricted to use Emacs. I wouldn't if I had to use Emacs. It's like this.
Okay.
Just don't use like Word.
So if you're in Windows, I want you to type. There's a space here and period. Explorer, spelling is right. Space, don't look for this on your keyboard. Explorer, space, then a period. This will open up Windows Explorer for you in the same directory you're in now. And just right-click New Document if you want to follow up, okay? Sorry, I forgot about the Windows crowd.
We are the Linux users. So.
Okay, yes?
When we do Git init, it's the .git file. Would it have a snapshot of the current project?
Well, it tells you I created an empty repository. That was the message said. It's a repository, but it's blank. Okay? So now I'm going to create a file. Yes? They don't need a console. Like in Windows, if they do right-click new document, it'll open Notepad or something. Let them call it .text, .txt.
Just create a text file somehow.
Yeah. Okay, so I want to make sure everybody is on. This is a good place to make sure everybody's on the same page. Yes. No, I want to just keep track of the file name and we're good. Okay, any other questions? No? Anyone needs assistance? Raise your hand. We have minions going around. Okay. Okay, so I created a file, and if you're in Emacs, Control X, Control S to save the file, Control X, Control C to exit Emacs. Okay, after you type something. So if I do, okay, so Emacs doesn't put any line. Okay. So if you do here, you should have a file that's called foo, or if you're in Windows, foo.txt. And let's see the contents of the file. It says this is foo.
How do we say it?
Control X, Control S, then Control X, Control C. So, what are we going to do now? We created a file. Then you want to know what's going on in your repository. So the first is, let me bring this up. You do a git status. Just you want to know what the state is of your repository. And it tells you, one of the important things we're going to learn today is actually reading these messages. Because Git is actually helpful, although it came from a Linux kernel developer. So it is helpful in its commands. So it says we have untracked files, and this file is called foo. Remember when we said color.ui auto? This is why we have this in red, actually. Okay, that's the thing that made this red. So, excuse me? Oh, it is? Oh.
Yeah.
Okay. So, Control X, S, then Control. Don't lift your finger from Control. Control X, Control S. Yeah. Okay. So now we have a file. The file is on our file system. We need to add it to the repository. Okay. So we do a git add, and we add foo, and we type foo. So what we're trying to do now is to add the file to our repository. So what happens when we add a file? It is now ready to be committed. Okay? And we have a new file that was never in our repository that's called foo. So what we do after that, we commit the file. So you type git commit to make life easy for everybody. You do a -m for a message, and then you put double quotes, single quotes, whatever you like, and let's type our initial commit. Okay? Everybody here? Now, some of you may have problems if the setup was not proper. Who's not with us? Or who did not get a message that kind of looks like this? Okay. So now, before, we had an empty Git repo, right? But now we added a file to the repo. We added the file and we committed it. Okay? When we add a file, it just takes the file, and puts it in a place where we can actually start committing it to our repository. After you commit it to the repository, a commit object is created. Okay? And that commit object, as John will show you, okay, this is where it comes in. Object. Each commit has an ID, is identified with an ID. And we're going to talk about that ID. And once you commit it, you're gonna have a pointer. It's written in C, so it must have pointers, right? So you have a pointer that's called head and pointer that's called master. Master is just a name that we give to the branch that we're in. Okay? So this is our commit. It's head and master at the same time. Okay? So thanks, Johnny. So if we come here and we do a git status, it says we're on branch master, like we have there, and there's nothing to change in our working directory. Are we good so far? Okay, so let's edit foo again. Let's say we made our first commit. Of course, you know, although I'm writing English, you can use this for code. Okay, just same thing. No way. Okay. Good job. Good job. So we have foo that's in our repo, right? Actually, before I do this, let's run this command again. Do you guys notice anything different? Yes. We have master here. And also you notice that we have objects. Okay? But why do we have 3 objects? We only added 1 file.
Initial commit, the initial repository commit ID,
Mm-hmm.
first one, and the temporary, which is untracked. The state, the files.
Well, if it's untracked, it's not in the index.
Status, ID.
What we have is actually the commit itself. The commit is an object. The commit itself, that's the circle. That commit, that's an object. We have the file itself, and that's an object. What's the third one? No, that's the third one. We have the file. We have the commit, the file, and the master branch itself, because it points somewhere, I believe. Yes. Sorry, head. Head, because head is a pointer, and it points to somewhere. That's where it is now. Okay, so now remember we edited foo, right? We said we made our first commit. So if I do a git status, what will I get? It says I'm in a branch master, and it says I have a modified file. Can you see it now? Now it says I have a modified file. What can I do with a modified file? You can just add it, or you can disregard whatever changes you have and go to previous. So what can I do is, one of the cool things you do is just do git add, and you say git add foo. So remember, foo was untracked, then it became modified, right? So after I did git add now, what's going to be the status of foo? So it is stage to be committed, ready to be committed, okay? And you notice the color is a little bit different here. That's in green, okay? So let's do a commit. So what will happen after I press enter here? What's going to happen with Johnny? Okay, so please pay attention to Johnny here. I made our second commit. So what will happen? Remember, we had master, we had head here. And then we made our second commit, right? Does it have the same ID as this one? It's a completely separate ID. And then, sorry, I'm not good with this. Then we move our head up there, and also master points there. Does that make sense? So we have 2 commits in our repository. Any questions so far? No questions? So if we do git status, yes? They're already linked because this commit actually already builds on this commit, right? This commit had 1 line, we just added an extra line, and it's just right after. Okay? Yes, internally we'll have more objects. So we'll have one more we have an object for this and an object for this. Okay? Yes?
You just added so we're setting up 2 types of file.
We're coming to all the what ifs. We have scenarios planned for all of them to make sure you get it. Yes?
Is the master and the head pointers to the commit, or does the commit point to the master? They point to the
If they're pointers that they point to the commit itself. So a commit is like a node in a tree, and those are 2 pointers. Like if you, in your data structures, you always have like head and tail, and they all move around sometimes. These are the same. Okay, now let's get interesting. Yes?
In our output, you see one deletion, whereas on your commit, it will be 131%.
Maybe you deleted a new line or something. Okay? If you want to see what happened, you can do like just git log stat, and it will show you actually what changed in every file. So I added 1 line here and 1 line here, and it will show you there. But we're going to get to git logs later. Okay, so let's get a little bit interesting. I'm going to create a new branch now. Okay, so you see we have a tree here. Think of it as a tree, and we're just thinking, okay, I don't want to work here. I want to just go along and do some changes on the side. Okay, I don't want to change what the master branch that I hear. So I just say git branch, create a branch for me, and let's call it feature. Because if you have a code that you're working with, and you want to add a new feature to it, would you rather not just and work on your feature aside without touching the main code until you're sure that the feature you added actually works correctly before you merge it with the main code that you have? It's logical, right? So what we're going to do is we're going to say git branch feature. So we create a branch that's called feature, but we're still in master. So we need to go to feature. Git checkout feature. So you notice if I do git branch, I'm in feature right now. Okay? So now, let's create a new file. I'm going to call it bar. And let's say this is not foo. I hate new lines in Emacs. Can never remember. Okay? So if you notice, when I branched from master, I have everything the master had at that time, which is foo in all its glory. So if I say foo, I have the complete foo. And I just added a file that's called bar. So if I do git status, what do you notice here? It says one of the first things you do, I'm on branch feature. That's something to keep in mind. Also, it says that I have a file that is untracked. What does untracked mean? It's not part of my index. Okay? So how do I make it part of my index? How do I stage it to be part of my index? Git add bar. Okay, so if I do git status, I see it here. Then I do a git commit. We are not ready for the... Okay? So now I have a new file that I committed to feature that is called bar. So let's see how that looks in the tree. So remember, we had our first commit where we added 1 line for foo. We have our second commit where we had the other line for foo. And that's our master. We branched out of our master, and then we went to feature. When we create the feature, head switches to feature. Are we in master? No. Head is where I am now. Okay, I would rather be my head than anywhere with my head than anywhere else. So head is where I am now. That was a joke, by the way. So head is where I am now, and feature is the active, hence the corner, is the active branch that I'm in. And this is the commit in which I added bar. Does that make sense?
Yes.
Questions? This is the time to ask.
So are feature and master like totally different things? I mean, like they're like totally separated, or like feature is like on the fringe of master or something?
So at this moment here, at this edge, feature and master are the same exact thing. But once you make this commit, feature is ahead of master by one commit. The only difference between feature and master is one commit, which is this one. So if you go to master, so if we if you notice that if I'm on master, I do an ls, I only have foo. Okay? However, let me go back to sorry, where am I? Oh, I created a new branch. Okay, is there any coffee here? Okay, so git branch, where am I now? I'm in master, so I just did checkout feature, and if I do an ls here, I get one bar. Okay? So, are we all cool here? Yes. Mm-hmm. What happens is, this index card is 40 bytes. 40 bytes of code. Okay? And when we created feature, what did we add to the whole repository? 40 bytes of code. Okay? 40 bytes and 40 bytes only. All we did is created a pointer to a specific place and gave it a name. The file foo is still where we left it. Remember, this we only changed. Excuse me?
You just have a pointer to the master.
Yes, it'll have a pointer to this blob, to the blob that this is pointing to. So this points to the commit, and we're going to see the data structure, how it works. The commit is pointing to foo in this case. Okay? This commit points to foo and bar. And foo is the same foo that's in this one.
And if we change foo, then we'll have a pointer.
We're coming to that. Okay? So what's happening here? What do we have in this commit? Come on, guys. We have bar. Okay? Is bar here? No. So why don't we just put bar back here? Right? I think bar is feature complete, for what it's worth. The best feature I ever added. I don't drink, so that's wrong. Okay. So what should I do now? I want to go to my master. Okay? Sorry, where am I? I want to go to my master. You see that I only have foo. And now I want to merge. I want to get all the changes that are from feature into what? Into master. So I just say git merge. And git merge works this way. You merge, like the simple command, you merge where you are with. You can merge two things that you're not even in. You can still do that. But just say, I'm in master, merge with me. Dear feature, merge with me. That should be a cartoon. Okay, now this is important. So, that's cool. I'm not ready for that. So what happened is, I'm in master, so, okay. Wait a minute. Oh, no, this is right this way. Okay, so remember, the first thing we did is we switched to master. So when we switched to master, this is like the corners, so now we're in master. Okay? Master was here. Master was here. And then we said, let's merge with feature. Okay? So we created a new commit that has what foo is the same here. And this is just an extension of master, right? With only one change. Did master change while this was changed? No. So it's only simply saying I just added a new file. So when I merged back, I just added bar that was here to here. So this commit has the two files. So the merge that I made is simply a fast forward, a simple link, one step up. You just kind of think of it, you collapse this, it's one line. I didn't need to change anything in master to merge with feature. All the changes in master worked. Okay? Does that make sense?
And where's the head now?
The head is where master. Where am I? In which branch I am in now? That's where head is. Head is always with me. Don't take it away. Okay? There's a detached head stage, but we don't want to go there. And I think there's a sticker for it, right? I think it's sticking on it. Okay. Any questions? No. Yes.
When we checked out feature, we could see foo and bar in the ls of master.
When you checked out feature. So, okay. First of all, let me do this. Oops, my bad. I didn't want to take this out. So, you notice that what we did here, when they updated, it updated from this commit ID. This is the commit ID. It updated from this commit ID to this commit ID. This is the ID of my new commit. And it did what we call a fast forward. Why was it a fast forward? Again, why was it a fast forward?
Because the previous commit was the commit which is already made in the new branch. It contains the new branch features. Plus you made something else or else, so it's basically you're moving a master. You're moving a master branch to something which is done in the future.
So essentially, I didn't need to change master other than just add what I did in branch. Okay? No fancy anything there. And this is almost never the case in code. Okay? But just so you know, it's simple and it's called a fast forward merge. So if I do, what files do I have here? I have foo and bar. And if I do get checkout feature, I still have foo and bar. So if I do a get log on feature, you notice that we are not ready for the bar here. Get checkout master, and then I do a get log. You see I'm not ready for the bar, but I actually have one more commit with it. That's the commit that I added in feature. Okay? Yes?
So after we merge, will the master have the same commit ID?
Let's look at this. Okay, let me open here. Okay, that's weird. What's the directory I'm in? So let's see. Oh. Okay, so git. Sorry for this. I'm not sure why this happened. As you can tell, I'm not a Mac person. Get checkout feature. So I'm in feature now. So if I do a get log -1, it tells me what the head commit is in feature. Okay. If I switch back here, sorry for the contrast. I am in. Oh, it's the same place. Okay. All right. Unscripted. And then I do a get log -1, 188D7, 188D7.
So that means that master is just pointing changes its address to.
Yes. No, master is a pointer.
Yeah, so that is just changing the address.
So master is pointing. Okay. Yeah. So now let's make it more interesting. I want to switch back to. Wait a minute. I think there's a mistake in that tree.
So when we fast forward.
Yeah, when we fast forward feature, all three should point there. Yeah, that's something that was the confusing part. Yeah, all of them point to that place. We're not in the branch yet. Okay, so get checkout feature. So now I'm going to edit bar again. Okay, one more change in the bar. Okay, and then I'm going to add the change. Okay, I added the change. So, and then I'm going to do git commit, changed bar. So now, you notice that after the 188D7 that we worked with, I added one more commit. So I changed bar, what bar looks like. Okay, so Johnny will show us that feature now is one step ahead. We'll give Johnny a chance to, yeah. And where is head? Okay. Yep, and head is with feature there. Okay? So feature is now one commit ahead of master. Now let's go back to master, and head is now at master. And now let's change bar. Let's change foo, sorry. Making it interesting. Excuse any spelling errors you may see. Okay, and what do I do now? Am I too fast, by the way? No? Yes? Who's not following with me? Who's not following? Okay, Jay, please. Ah, okay. Kids and their toys. Okay. So before I add foo, I want to show you the nice command that's called git diff. Git diff actually gives you the difference between the current stage of your directory with what you have in the index. Okay? So in this case, I only changed foo, and the change is one line addition. Okay? So this is a nice way of doing it. Of course, if you have too many changes, you can just you can specify the file. So you can just say git diff foo, and it gives you the changes within foo itself. Okay. So if we do git add foo git commit changed foo in master ignoring feature. So what happens when I do a commit now? What happens in our tree? Yes. If it's too long, just press Q. It should take you out of it. You're out? Okay. So now, yes.
Why do you need to add again?
I changed it.
So every time you change it, you actually add it?
Yes.
Really?
Yes. So, oh, you're coming from an SVN background, maybe. Yeah. Yeah. We're going to talk in a minute about the stages of files in Git formally, and that will explain it for you. Yeah, there's a reason anybody who used version control hates Git, and this is one of it. Okay, so what happens now is master now has one more commit. Yeah. And our tree collapsed. We rehearsed this in fast motion. Apparently, we're better fast and slow. Okay, so master is the active one, and this is head. So this is our when we did the fast forward, we stopped here, right? Where we had foo and bar both in the same place. In feature, which is inactive now, we add changed bar. In master, we changed foo. Now, do you think this is a An easy change, a fast forward change?
No.
Why not?
Because one is lagging behind. Both of them are in different places.
Okay, but they're different files. So what?
So when
They have
you,
different versions of files.
Imagine this. You have two people working on a project in Java, and one of them has a student class and the other one has a professor class. And for some reason, they had the student add GPA as a float. And then one user changed it to a double, while the other person changed their professor ID from a string to a number. Will it work? It's only, they're two separate files, they never touched each other. Will it compile for you if you have a course class that uses both? It won't compile, right? So this is not an easy fast forward change. You actually need to work at it. You need to make sure that there is no problem. Okay? So what we want to do now is actually merge, right? So where do we need to go if we want to? I want to merge into master. So I go to feature, right? No. Okay, people are still awake. Awesome. So I want to merge with master. I need to stick around in master, and I say git merge, and say what after it? Feature. And it told me, okay, I actually need to write down a message. As soon as you see Git asking you to put in a message, you know there's something that you need to check. Okay? So if this came up and you were not expecting it, you should open another terminal window and go check the diffs. See what's going on. Okay? Does that make sense? But for our case, we don't see it as a problem. So I will just accept it, accept the error, and it says, I merged by the recursive strategy. So we have this. Okay. So fast forward it to here. This is the when we edited bar. This is when we edited foo. Now we wanted to merge it, so we created a new commit that has the changes in foo and the changes in bar, and I merge it with master. Okay, and this is a classic Git branch. Yes.
Oh, I did something different, and I got a merge conflict that like failed auto merge.
So you need to go. That's going to come in a couple of steps forward as far as we're concerned. But essentially, you need to go into the file and edit it. Maybe you edited like foo and bar in feature, and then you edited one of them in the auto branch. So does this make sense?
Yes.
Johnny worked hard at it. It should. Any questions? I would really love a couple of good questions here. Yes?
Where's feature now?
Feature is still here because we merged feature into master. So master is the merged one, feature is still there. And we'll double check it. We'll go check the logs right now. Okay? Let's go check the logs. So we're in master. If we do a git log, let's do the last two entries. We have D95, which when we changed foo, can you point to D? Oh, did you open it up? Can you point to D95 for me? That's the one in master, right before the merge. That's D95, and then we have the merge between D95 and keep this number in mind, D1E. Okay, and let's do git checkout feature. Let's do git log -2. You see the D1E? That's actually the last commit we have in feature. So the top one, where the head now is at feature, but where master is pointing, it's a merge between the last commit in feature and the last commit in master. Does that make sense? Do you guys get this? This is like 75% of Git, right there. Yes. I really don't know why the naming is that way, to be honest. Like, I stopped, like, after seeing a command that's git re, I stopped asking questions about why things are named. Or like octopus merge. There might be a reason, I don't know it, to be honest. Yes. Yes. So let's go to, okay, just so clear, let's do cat foo cat foo bar. That should be a joke somehow. Okay, so this is foo. We made our first commit. This is not foo. One more change in the bar. Okay, and then we do git checkout master, and then we repeat cat foo bar. This is foo. We made the first commit, making it interesting. This is not foo. One more change in bar. It's just the end line was off. So this one had the changes from both places. Hence its place in the tree. Okay, now one cool thing, is everybody good here? So if I do Git LUG has a lot of cool features. I use it in grading a lot. But if I do git decorate, and then I say, well, show me a graph of everything. Okay, that's insulting. You can see in the bottom here, wait a minute, sorry. In the bottom here, this is our initial commit, our second commit. And then here is where we created bar, right? In feature, when we merged it. Then we changed foo and master. And then we went, and here is where we got it, where it became interesting. Green is the master, okay? So you notice here we did a change in bar, and we did a change in the master for foo. And here is where we merged them both. So you can actually visually see the branch here. Okay? Who needs a GUI when you have this? Who is the GUI guy? Okay? Now, is that cool or cool? That's awesome. Not only cool. Okay. Well, if I remember your factory project, that was actually your role in your project. You actually color-coded the issue tracker, the labels of the issue tracker. I still hate you for that YouTube video, by the way. Okay, so what did we do in this set of code? We created the repository, we worked on master, we added, we committed, we branched, and then we merged. And we covered the init command. What does init do? Creating a repository. So it's for, you want to start working on code, just type git init, and you have a Git repo where you are. Okay? We know how to add files, commit files, branch, merge, and check out. What is check out, by the way? I'm so happy today. Unless you came already prepared, which means I wasted everybody's time. Okay. So, yes?
So even though the master and feature are now merged, it's still separate branches.
Master is the merged branch. Feature is still on its own.
Okay.
Feature is still where it's at, with no changes in foo applied to it. We merged feature into master, so master is the feature. It is the one with all the features. Branch is still feature is still where it's at.
So like that means that we can make more comments from feature and then like we can merge it to.
Yes, and we're gonna go over it in a minute. We're gonna show you a flow how it works. No, it means you're understanding it and you're actually expecting what's coming forward, which is awesome. Okay, so and this graph is answering what your question was with respect to the life cycle of a file. How does a file live in Git? If the file is not in the index, it's simply an untracked file. We don't have history for it. It didn't exist in our repository before. So if I do a git diff, will it give me anything? It doesn't have anything to compare it to. So I do a git add for the file. When I add the file, it becomes an unmodified file. Okay? And I could also remove it, but let's not worry about that. So it becomes here. Now, I can edit the file more if I want, but let's make it easy for this one. After it becomes an automatic file, I added it to my repository. It's like any file that already existed there. So if I do a git add will stage the file. Staging that's different from SVN and any. I'm not sure about Mercurial, but it's different than SVN. You can think of the file has 3 states. So you have your working directory, what you're working with now. And you have your staging area. The staging area is where you put the files that you want to combine them for a commit. So you're building up to a commit, you edit one file, and you just do a git add. So you move it from here to the staging area. This is your index. The index, what goes into the index? Committed code. Anything that's not committed is not in the index. So staged area is like an in-between area. So technically speaking, and stop me if you don't understand this, you can have a file that you edited and now it's in the stage area. Now if you go to your working directory and you change it, okay, and you change that file, I need an extra piece of paper, sorry. And you go and change this file. So this is the staged version. What's this? This is the modified version, right? So technically, I have 3 versions of the file at this stage. I have one that's in my working directory. Okay, that's modified. I have one that I staged for a change. I did a git add, and it's here. Okay, that's when it was green. And then I have the actual one that's in the commit, that's in my index. Is that clear? Okay, you get it or a little bit iffy? Yeah, in SVN, if you add the file, that's it. You don't need to add it again, you just commit it. But conceptually in Git, they want you to commit a lot and commit often. Okay, so in SVN, you generally don't, a commit means a write to the server. And you generally don't write to the server unless you're really sure. Okay, so that's conceptually the difference. So
if you don't add the file then before you commit it, what is the
let's give it a try. The proof is in the pudding. Is that a right example? English is not my first language, so I'll take it easy from there. So let's do a git status, and let's say sample, and I added that to foo. So if I do, so foo has an extra text at the end, okay? And I do a git status, you'll see that foo is modified. Let's do a git commit. Did not add. What should I get? No. So simply there is no changes added to commit. Okay? I ruined foo. How can I fix it? I don't want that change. It was just for illustration purposes. Read. It's an awesome tool. Just read. Use git checkout -- file to discard changes to the working directory. Reading is awesome. It's like when you go to lab and the error is like square in front of them. Line 27, null pointer exception. I have a problem in my code. I couldn't figure it out. It's in line 27. Okay, so if I do get checkout, now this is a t-shirt question. Why the hyphen hyphen? Why the hyphen hyphen? Yes. Correct. Because get checkout actually takes me to a branch, right? But if I give it a file name here, it knows that foo is not a new branch. Remember, I created a branch called foo by mistake before. I'm not switching to a new branch. I mean, it's a file. So if I do get status, the file where it was. Okay? Thank you. That was a good question. T-shirt question, right? How many do we have left? I don't want to overcommit to T-shirts.
A lot of small and a lot of extra large.
Oh. Okay. So are we clear on the difference between staged, modified, and unmodified? An unstaged file is kind of this weird place. But we have unmodified, modified, and staged. When you add it, it is staged. And then when it's staged, you commit it, it goes into the index. And when it goes into the index, it becomes what? If the file is staged, you commit it to the index. After you commit it, it's written into the index. So is it different from what's in the index? No, so it's unmodified. Let's say it again. I have an unmodified, I have foo. I added sample to the end of foo. Now it's modified, right? I said add, it became staged. I did a git commit. Now, with the added text, is in the index, which means that what's the status of foo now? Exactly what it is in the index, which means it's an unmodified file. Because my reference for a modification, is it the staging area? No, it's the index. Does that make sense?
So then the index and the working directory become the same thing at that point?
If for unmodified file, the head in the index is what the working directory looks like. So if you do a git status and you get nothing changed, it means your working directory is like the head in the index. Okay? Okay, I hope this is clear. Now let's talk about the commit. We talked shortly about the commit. Remember when we said exactly in, exactly out, and that equals problem? How do you recognize such a problem? There's a way that we're already using. You can tell that the guy who created this is actually a file systems guy. I'm not going to step on any file systems documents. So, essentially, a commit, the data in a commit is the content of the file. Not the name of the file. The content itself of the file. The text that's inside the file. And then you add to it the author, the person who created it. You add to it the date that he created, that the commit was made. And then you add the commit message that you put in. And then the parent. Remember you collapse your trees so fast. And remember the previous commit, the parent. How many parents can a commit have? One. But when we merged, remember we had 2 parents? Right? When we merged, it says this is a merge of this and this. We need to go to the log again. So let's do git log. Oh, sorry. It was, let's see, git log, decorate, graph, all. How many parents does this commit have? It has this commit as its parent and this commit as its parent, right? You see? Merge. It has 2 SHAs, two IDs. I didn't want to say. The D95 and the D1E, right? So it has 2 parents. It's a tree. It could have 2 parents. Actually, it's more progressive than that. It can take n number of parents. Actually, I just read the statistic that the biggest merge in the Linux kernel is a commit with 12 parents. Good. Silence is better than any joke that I can insert here. Okay. Really? I had like half of the presentation left. Oh my God. Okay. I'm bad timekeeper. Okay. So let's see what we want to do here. So you understand, let me go over the important stuff. Everything I say is important. So now what happens if I change the file? The commit changes because it takes all that information and creates a hash out of it. It uses SHA-1. Creates a hash out of it. And if you create a hash out of this information, any single bit that changes, by definition, the whole SHA becomes different. Right? Does that make sense? So essentially, if you want to go back and you want to change any single thing, be it the content, be it the author, be it the previous commit, be it the commit message, you're going to change the whole ID of the commit, which means that you're actually creating a new commit, and that other commit is still going to be there. Does that make sense? Yes. And what's going to happen to that commit that's at the end? Git has garbage collection in it. So after a couple of weeks, if that's not reachable by any other branch, it's just going to go away. So are you actually removing something from the history of the file? No, you're just rewriting history. You cannot erase something and keep the same commit ID as you go along. If you change anything, it's by definition of the hash. You change the ID itself, so you're rewriting history. So in our case, our commit points to a tree. Remember the snapshot? that we talked about earlier. Snapshot is essentially a tree structure of the file system that I have, which points to different files. Each file has its own SHA. Remember when we said when we saw the .git, we looked into it, and then we had all the addresses. These are the SHAs for the individual files. And this tree, which is a list of all the files, has its own SHA, which is also an object in our index. And then the commit has the tree along with the author information, the person who committed the code, the date, blah, 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 blah. And that's another object in my index. So if I have a collection of them, that's my tree. That's this, but prettier. Okay? Essentially, this has its own SHA, points to a tree, and every commit points to its parent. So this is the last commit, this is its parent, this is its parent. Does that make sense? I'm glad it does. And somebody asked me a question, I believe somewhere here, where, okay, how do I work with code? Well, essentially, Git is based on the idea of committing often, committing fast, and also branching a lot. So whenever you want to do something, you're always advised not to touch your code. Master should be this pristine, nice branch with everything cool in it that works most of the time. Okay, let's be more optimistic. You want to develop something, create a development branch. And then you want to add a feature, just branch out of your development branch, add that feature. Once it's done, merge it with develop. That way, if somebody else is working on your development branch, you won't. It's still in a better working condition. You don't add something unless it's feature complete. And the good part is, develop will have all the history that's part of this feature and part of this feature too. Because remember, when we merged them, we had all the history in. Does that make sense? Also, once you merge it back with master, all the history is here too. I see blank faces.
So does the log of feature developed and the other feature come into master?
And the other feature come into master?
Whatever logs you had developed.
Yeah, it all comes in. Yeah, of course. Okay, let's say in feature you create another branch that you can never reach it afterwards. That's not gonna be, the log is not, if it's not reachable, the log will not have it.
Well, what do you mean?
Let's say, for example, you created a branch here and you never merged it. There's no point of keeping the history of it as far as master is concerned. You may have it locally, but if it's not reachable, why put it in? Okay? Any questions? Yes? Yes, it's a SHA-1 hash of the stuff we saw. And yes? Okay, this is a question more about how hashes work. I'll give you a code. Okay, they said if each and every Linux developer, okay, was committing to master since the day Linux was born, and had to commit every minute, okay, it will take 1,200 years to get accomplished, to get flash. If each developer committed once per minute for 12 years, okay. So this is a more fundamental question about how hash functions work, and this is not, we can talk about it after the talk, but this is not the time. Yes?
They have a way of preventing clashes from randomly happening.
Clashes from...
Like if there's two hashes that like, is it
possible? Yeah, if let's say for some reason a collision was found, I think you can actually write a paper out of it because you proved that there's a collision. That's one. Two, it actually does a check. First of all, to check that actually the SHA is correct. It's correctly calculated. Like you didn't edit something, you didn't go physically in the index and change something. Okay? It checks for that, and it also checks that there are no collisions. Yes?
And then after your collision, so you can't commit.
Yep.
And you commit again, and then you have a different one.
Yep. You change the time. If you change the time, the commit ID will change it too. Yes, you had a question back there. Excuse me? Yes, we just yeah, and that was I didn't realize I didn't have time. This was actually set number 2. We were gonna talk about conflicts. We can, okay.
Right now, like we have 10 minutes left. We'll stay here for like probably even like 30 minutes after. Like this isn't a lecture or a class or anything, so you can take any time if you guys want to go. But I'd encourage you to stay and learn about how to use Git.
Yeah. So what I have planned is as follows, and you can tell me what you want me to do. Okay. I was gonna talk about remotes, which is essentially how to use Git with a server of sorts, or with a repository that's not only working where you are right now. And then from there, we'll graduate to using actually a remote server that's on a different machine, like in GitHub. Okay. And from there, we're gonna see how you can work with different people. I'll try to speed up. Okay. Anyone wants to change anything? No? Good. Let's get going. Okay. So as far as we're concerned now, we were only working with ourselves. So we didn't need to keep track of people. Nobody else needed to work with our code, because if someone else wants to work with my repo, they couldn't use my .git because it reflects what I have, right? So what we're going to do, and by the way, if you're following up online, this is called Hackset 2, if you want to look up the code on the Git repository. Okay. So what I'm going to do now is I want to make a place where I can actually tell people or tell myself to go there and grab the files from there. Okay? So I'm going to do a clone. A clone is what it is. It makes a copy of the repository. What does it make a copy of? My files? Which includes my files? How about a more accurate answer? Excuse me? The directory? Not really. Come on. Not necessarily, not only the branch. I want to clone the repository. I want the whole enchilada. And I can give it to anyone so they can work with it. They have all my history, but not my working directory.
All the changes that's
It's the index, actually. It's the .git directory. Remember I said you can just grab the .git directory, push it somewhere, and people can use it, right? So here's what I'm going to do. I'm just going to say git clone, and I'm going to create what we call a bare directory, which is essentially a directory that has the .git as the root. So it's not going to be somewhere where I'm going to go and edit code. It's just going to be somewhere where I have the repository. So I'm going to say git clone, bare repo. Repo is my directory that had my code in it, right? Are you following? Repo was where we were working since we started. And then we're going to do remote, which is the new bare repository that I'm creating. Cloning into bare repository remote. I'm going to go into remote. And if you see here, does this look familiar? This is the tree structure that I have here. It's essentially a .git, but as a first-class citizen of the directory. Does that make sense? I'm going to try to hurry through, so actually, let me hear you interrupting me if you have any questions. So if we actually go into my repo and I do tree.git, you will see that it's essentially the same thing. Okay? Now, remember when I'm committing and changing, I'm doing it in my own index, right? Well, what if I want to actually have remote be the server that I'm grabbing from? So I report all my changes to remote, okay? So let's make it easy. Let's say git clone. So I'm going to clone my remote into work. So I go into work. What will work have? Will it have the .git files opened up? Or will it be actually a working directory? It is a working directory that has foo and bar. And if I do git log, for example, it has the merge that I did last. Okay? So essentially a copy, so if I want someone to use my remote, I just point them to where that remote is. Abstractly speaking, it's just somewhere I tell Git to go grab the files from. So if I go to work now, I am at work, and I say git remote -v, it tells me, oh, I actually have a remote that I'm talking to. Somebody I could push my code to, and that somebody is called blah 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 / remote. And the nickname for it is origin. Origin is just like master. What's master? It's a pointer in our tree. Origin is just a nickname we give to the remote. Okay, it's a default nickname that we give it. You can change it. It doesn't have any special meaning of itself. So now what I'm going to do a git checkout -b bug fix. Did I create the bug fix branch? No, this is a shortcut. This says, okay, check out a branch that's called bug fix, and by the way, create it while I'm at it. Okay, and that's what the -b does. So if you do here git branch -a, it says I have bug fix. And it also tells me, by the way, on a remote, I have a branch that's called feature and a branch that's called master. Okay? Is that too soon? Remember, our repository that we had feature and master, right? And this is telling me, by the way, your remote, the remote that I added here, we call this remote. This remote has feature and has master. And of course, it has head, which points to me, my master. Okay? Yes?
How come I didn't say feature branch, feature local branch?
Feature local. Okay, so when you clone a Git repository, it clones the default branch, to be more specific. Generally speaking, the default branch is the master branch, but just in case you configured your Git repository to have a different branch as its default branch, that's the one that's going to be cloned. If you want to clone this one specifically, you can clone using a fetch command. Okay, and we're going to get to that in a minute. So what I'm going to do here, I'm in the bug fix branch. I'm going to create a new file, and I'm going to say new bug fix, and I'm going to put it in a file that's called buzz. Okay, so I like buzz more. So now I have 3 files. So what will I do if I do a git status? What will I see? Come on. Okay, so I have an untracked file, git add buzz, git status, it's a new file, and then I commit it, git commit new file. And now it's committed. So where is buzz now? Is it in work? It is in my work directory. Is it in repo, the one that I had before? No. Is it in, or is it in a remote? No, it's still local. Remember we said decentralized? Okay, it's distributed. So what do you do locally? It doesn't go up there unless you tell it to. Okay? So if you do a git status, it tells you, well, there's nothing to commit. It's a clean directory. So what we want to do now, let's go to master. Oh, sorry, before we go, let's go to master. I think this is the faster approach. So git checkout master, and then we merge. Okay? What kind of merge will we get? We had 2 merges, recursive and fast forward. Why fast forward? Come on, somebody from that area. I'm said from that area. Come on, why a fast forward? I just added a new file. So we did a fast forward merge that has nothing to reflect except adding the file. Of course, a fast forward merge, a recursive merge, there's a heuristic that Git uses to determine which merge to use. That heuristic may end up being wrong, and you need to go back yourself and change it. And you can actually go and configure these heuristics internally, which is some Git voodoo there going on. But it's just a heuristic. It's not necessarily a rule. It's not necessarily the right thing. Okay, you may add a file that will make your project not compile at all. So keep that in mind. So now, if I do git status on master, I get some interesting message. That message says, oh, by the way, I am ahead of origin master. What is origin? Origin is remote, right? Origin/master is a name that represents that remote. Okay? And it's telling me, by the way, you're ahead of origin master by 1 commit. Now, am I guaranteed 100% that I'm ahead of remote by 1 commit? Why not? The origin master could have changed. So I know from the last time I pulled, the last time I cloned, it's only 1 change. Okay? So what should I do now? Who said pull? Okay, he got a t-shirt already, so he gets a sticker. Okay. You should actually do a pull to make sure that nobody changed master. And if there are any changes, you fix them before you push and maybe cause problems. Okay? And if your code has a test suite, you might want to pull. If there were changes that you needed to merge, you want to run the test suite before you push. Okay? So, but for now, we're just going to say push. And where are we and we just say git push. And that's it. It said, blah, blah, blah. I'm compressing. I'm sending lots of words. And say, okay, I'm sending it to this remote. And I'm sending this. And we're going from this commit to this commit, from your master to their master. Okay? Any questions on here so far? Repeat it again. Sure. So instead of making another branch, let's add something to the, I'm not sure you can see the one here. So if I say echo yet another change, and we add that to buzz. So if you see buzz now, buzz has 2 lines. So if I say git add buzz, git commit yet another commit, and then, okay. So now if I do a git status, it tells me, well, you're ahead by 1 commit. Okay? So if I want my work to be on the remote, I need to push it. And that's what I did. We already have repo, right? Did I erase repo? I didn't erase repo, right? So let's exit work and go into repo. Okay, let's go back to work and let's see git log 576D, right? And now let's go to repo. It's still on 18D. Okay? Now, does repo has a remote, git remote, does it have a remote configured? No, as far as it can tell, it's an only child. It's like immaculately concepted or something, whatever the word is. So what should I do? I should actually add a remote. And I give it the path to that remote. Oh God, what's the path? Okay, I'm just going to say like this, remote. Okay. And I'm going to call the remote. Actually, the default name is origin. Git remote origin. Okay, something more. Okay. Git remote add, and I'm giving it a name, and then I'm going to say home / what did we call it? Remote, right? Yeah. Okay, does this command make sense? Remember, I didn't need to add a remote in work because I cloned it from there. So it knows where it came from. But this one, it doesn't know. So I'm saying, use that one as your remote. Okay? And I just added it. So if I say get remote -v, same thing I got from that server. So I say now get pull. Oh, because I never pulled before, I need to say get pull from origin to my master. Okay, origin is what I'm getting it from, and I'm pulling it to my master. And now if I do a git log, yet another commit. Okay? So now you see that it recognized there are changes and it pulled it. Essentially what Git did, they all have the same tree at different places, right? So when this wanted to pull, like think about it. how did it know? That's a repository it never seen before. How was I able to pull from it? It could be anything. It could be, for all I'm concerned, the CS201 factory. How was it able to pull from it? It just looked for the common commit. And it found that, well, this commit that's in repo is actually this commit in origin, in remote. And it just pulled the rest of the tree, plugged it in here, because they had a common commit there. Does that make sense? So if you understood what we had there, yes?
So what happens if you made a local change and original change
We're going to get to that with Johnny in a minute. Okay? Thank you, Johnny. Okay, so now, well, it's nice that I have the remote on my own machine, but what if I want to share with other people? It's good to have it in a common machine, right? So let's go back. Let's see if I have other slides. Yeah, these are not the commits you're looking for. So we're going to go to GitHub now, and we're going to learn how to use a service like that to host our Git repositories. Okay? This is actually, I intended for this to be a longer component, but I didn't think I had enough material to cover the time. So let's go to github.com. Just a piece of advice. How many of you went to interviews and they asked you for your GitHub username? I'm interested. 1, 2, 3. So it's becoming a thing now, where actually people ask you for your GitHub username when they're recording you to see your code, see how your code is. Is it nice? Is it not nice? Do you play well with people? How often do you code? Is it clean? Is it not clean? It's better than actually looking at you coding offline, which is scary in a way. But, right? So let me go to my, and GitHub is becoming more and more good at actually showing how bad you are at coding. So I actually show, okay, which month of the year that you're actually coding right. You can see I had a very slacking summer where I didn't code anything there. And as soon as the semester started, I started going haywire, and you don't want to see all the private repos I have access to, otherwise it's going to... Okay, back to our topic. So I want, now me and Johnny, you want to collaborate on this project. So in order to do that, I'm going to create a new Git repository. GitHub gives you free public repositories. However, if you go to github.com/edu and you tell them I'm a student and you put your USC email address, you tell them I'm a student, they give you a free micro account. That account gives you 5 private repositories that you can use for your projects, et cetera, on campus. So like you have one for your thesis, one for whatever project you're working on. Thank you for coming. Thank you. And let's put the repo name. So let's call it, I'm blanking. Submissions v2.1. Okay. That's an internal joke, by the way. Okay. Okay, Git Workshop, one word. USC LUG, it's going to be public. Now, remember, I already have a repo. Do I need Git to make the repo for me? I just want to push all the history I have the same way I did with the bear when I made it, right? So I'm going to say, no, do not initialize the repo for me. Now, if I'm going to start from scratch, I'll say make a repo for me from scratch and start it from, and I'll do it there. But in this case, I'm saying create it from scratch, and it's actually going to give you some instructions. If by mistake you didn't initialize it and you want to start a new repo and push it here, so be it. But if not, it tells you how to push an existing repo. So remember this command? Does it look familiar? Does this command look familiar? The same way we added our remote. So let me use it here, copy it, and go here. So this is my repo. It has remote as its origin. Okay? So I'm going to paste this command, and I'm going to say, okay, let's use this repository as my remote. What's going to happen right now? It's going to, you get a t-shirt? No, he's going to get a t-shirt. Okay? It's going to choke. Why is it going to choke? Why? Come on, look at the command. Look at the 3 lines we have here. Yes, I already have something called origin. So I actually need to give the remote a different ID. So I'm just going to call it GitHub. Okay? And I create this. So if I do git remote -v, it shows I have 2 remotes. So now I say git push all my code to GitHub from my master. GitHub from my master. What's going to happen now? Why did I get this window? Yes, this is why we created the SSH keys. You actually need to go to GitHub and tell it, this is my public key. This is how I authenticate. Okay? If you notice in the URL, the user is git@github.com. Your username is not git. And this is the same URL for everybody. So how does it know who you are? By comparing the keys. Okay? So, since we're in a little bit of a hurry, I'm not going to show you how you insert it, but the instructions are online. Mine are already set, so I'm going to put the password, the passphrase from my commit, and if we go back here, it pushed it. So if I refresh, now, you see bar, buzz, and foo. And actually, there's a cool feature here where it says network. That was the branch that I made, the merge that we made before. Okay? Pretty awesome, right? You should see the contributions page, but once you work with people. So in order to work with Johnny, although my repo is public, I actually need to add him as a collaborator. Oh, it needs my password. What is my password? Okay, so no. Okay, that's you. That's your mug. Okay. Oh, what's yours, Jay? What? Can you say it louder, please? WH. Dude, I'm running on empty. So is this you? You don't have an emoticon. I'm not adding you. Okay. Okay. So let's go back to the repo. So now I can actually go back, and GitHub has some cool things. Like, for example, it can show you your code. If you notice here that I only have the master branch. But if I go to here and I say git branch -a, I also have feature. So if I want to push feature to GitHub, now you could have 2 people working on feature and 3 people working on bug fix, and they're separate people, okay? But if the branch is only yours, you don't need to push it. But just in case you want to have fault tolerance, you just git check out feature, and then you say git push, what is it? GitHub, did we call it GitHub? Feature. Wait a minute, could not. Oh, GitHub. Okay, GitHub. Cool. So now, if I refresh the page and I go to master, it actually shows me feature. Now, is this cool or is this cool? It's actually, now that you understand what's going on, it makes a lot of sense, right? Like, it is really cool. Like, there's a microphone on, but I consider this like CS porn, okay? It's like really great. Like, you get, yeah, I don't want to go anymore. Okay. So, and one of the cool things here, I'm not gonna you know what? Let's commit something. Let's make sure we can actually push to GitHub. Okay? So let's go to master, and let's add some more files to foo, for example. So I want to eat, and I'm gonna take that to, it should be in bar, but so if I do a git status, git add foo, so how git commit, hopefully done. And then what do I need to do? If I do a get status, what nice information I will get? Wait a minute, something is wrong. I set it up, but it's not the default remote. That's why it's not complaining. But, okay, I made a commit. Now I want to push it to the server. So let's go. I'm going to say git push to GitHub. And I just spell it wrong all the time. And push my master to GitHub. Fine. Done. Cool. Do it. And uh-oh. 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 It tells me my push was rejected. Why would it be rejected? My contributors added code. Okay? Shame on you. Okay? Now you get what's going on? Now you see how in a collaboration environment things can happen? And this is what you get when you work on teams. That's why, actually, it's telling me. Remember, reading is a really, really good tool to use when you're coding. It says, I'm trying to push your master to master. I tried to fetch first. Oh, failed because something there didn't work out. You need to do a git pull before pushing again. Okay? So let's do a git pull. Sorry, I want to git pull from, because it's not the default, so I'm going to git pull from GitHub to my master. And it tells me, okay, so I went to master, and I went to the master there, and I fetched their head, and I actually got the GitHub master to your master, and I did an auto merge. But there's a conflict in foo, so I couldn't really merge it for you. Okay, automatic merge fail. So what should I do right now? I need to fix the conflict. How would I fix the conflict? GitHub save me. How would I do it? The old-fashioned way. Actually open the file. Okay? So where is the conflict? It's in foo. And here you go. So you notice that I have these nice arrows here, and the Subversion people will see this as familiar. It says, this is head. Making it interesting, I want to eat. And then there's this line, and there's making it interesting, really interesting man. Thank you very much. And then it gives me a number here. Okay? Now, what it's telling me, it's giving, okay, this is your portion of the code, and this is the remote portion of the code that you just pulled. And they put a line in the middle, and you said, this area, clean it up. This is where your conflict is. Now, if I have a big file, it could actually be, I could have multiple locations with that. Okay, it could be some here, and then some, like you could have edited a method down there, and if you have a long class file, you can have it in a lot of places. Okay? So, what is head? I hope it is mine. I want to keep it. Head is mine, remember? It's my pointer. And what is this? This is the commit ID for, so if I refresh and I go check the history, they went wild there. Okay, so 14B12, like he wants me to fall for it again. Okay, 14B123, this is the commit, okay, that he has. So what I'm going to do, I'm going to say, first of all, I want to make sure I remove this. And I'm making it interesting, really interesting man, but I still want to eat. Okay? And now I should just push, right? No. Who said no? Why? I didn't commit. Who said that? So remember, git state, you should wake up from your sleep, and as soon as you wake up, say, git status. You check your status when you wake up, okay? So, oh, you notice there was actually a new file that Johnny added. That's called readme. But okay, actually my foot started to hurt right now. So what did you notice about the difference between foo and readme? It did a fast forward on readme, right? I didn't have it, so it did a fast forward on readme, but it didn't know what to do with foo, so it just let me take care of it. So readme was already added, it was already staged. Okay? So I'll do git add foo. So if I do, and do you notice here? And we may not have time to talk about it, but this is a way of like just putting the branch name in your command prompt. It tells me that I'm actually merging. All conflicts fixed, but you are still merging. Use git commit to conclude merge. Reading is amazing. So git commit, and I'll give it a message, merging. Git push. Why? Because Jay thought it was nice. Jay, I'm getting tired. Okay, git pull. And thank God, this is an easy merge that I don't need to be involved in. I hope, I never know. And then I just do git push. And let's go to Git Workshop. Sorry, let's go back to the commits. And you can see that this was Johnny's, and then I actually changed it. And then Jay's actually came, it didn't physically come after mine, but because this merge worked in parallel with Johnny's, it actually put his after it. Then I pulled Johnny's, and then I did the merge, and now at least my commit is at the head. Now, one quick comment that we're not going to go into detail about. Remember when I told you use the email that you have for your GitHub account? That's actually how GitHub ties your GitHub account with your commits. Because if you notice, if you go to Git log, it says commit number, whatever, if it's a merge or something, the author name and email. So it checks this email with GitHub. If it finds that email verified with a GitHub account, it ties that GitHub account with the email, and it displays you as the user responsible. So if you go to, let's say here, to the graph section, and you see the contributors, you actually see the people who contributed, and it's tied to their accounts. And I know people who hate me just for using this in their course. Okay, any questions so far? Yes?
We see the decorated graph about the
Oh,
so we can see the branch.
okay, so let's see, git log. Does anyone remember the command? Decorate, graph. This is actually nice. So the different colors, oh, there are a lot of colors now. So you can see this is where we started. We branched out when we learned how to branch and merge. And then we just went fast forwarding from there. Then we did another branch. Then we had other users come in, and we had one more branch, and then we went back there. So if you want to see, oh, by the way, if you want to know the color legend, it tells you what is your head and which one is a remote and which one is your master. This is a remote. This is my master. Okay? If you go to GitHub and you see the, sorry, not the branches, you see the network. Okay? And why are all the branches under my name? They definitely contributed, but why the branches are under my name? I'm the one who merged. Okay. However, if you go here, it tells you who made the specific commits. Okay. Did we have any other things we want to cover? I'm toast.
All right. Thank you guys for coming out.
Thank you, guys.